air hose of science. Now, a submarine would have tanks on board that would act as the air supply. But since we don't have a real submarine, we just have our model submarine of science, we're going to have to improvise. So when I turn the button of science, we're going to watch the submarine blow all the blue water out and fill itself with air. This will make it less dense than the water, or weigh less than the water that it displaces, and shoot to the surface. Ready? Science! There we go, just as science predicted. As you can see, the model submarine of science is now out of blue water and it's around in the ocean. So, it worked. The submarine of science became less dense, or it weighed less than the water it displaced, so it rose to the top. Now, that's a pretty good idea, but there are a couple things that can go wrong with that. One of those things is
thermodynamics.
And the idea with that is that as a gas expands, it gets cold. And that's because the gas is having to do energy on the environment. And a really good source of energy is heat. There's a really good way to demonstrate that, and that's with canned air. You know, have you ever taken a thing of canned air and just sprayed it? All of a sudden your hand gets really cold? Well, I'll show you how with science. So, if we take this thermostat right here and measure the temperature, you can see that the can is 53 degrees. Now if I take this and a little bit and measure it again, it's now 43 degrees. That's 10 whole degrees in just a couple of seconds.
That's cold.
So imagine if a submarine, hundreds of feet long, tried to get rid of all the water inside of it and rise to the surface through a tiny little nozzle. Well, any water that would be residual would freeze. That meant that when the USS Thresher tried to get all the water out of its system with this air